So in the previous video, I set you a few questions on graph transformations and how we would go about them and what we would do to manipulate them. In this one, I'm going to take these questions and I'm going to show you the solutions and how you need to think about these types of questions when you're working with them. Just a quick refresher for you though, this was what I asked you to do. So I gave you that graph there and I asked you to sketch the following graph transformations marking on all key points. So y equals f of x plus 1, y equals 2 f of x minus 1, and y equals negative f of 2x plus 1. Now, a quick hint for you. When it says all these key points, whatever points they mark on to begin with, when you've done the graph transformation, you have to show where these key points have gone. That's what they mean when it's talking about that. So however the graph has changed, this point here will have changed somewhere. You've got the full coordinate of it, 0, 3. Where does it end up? That's what you have to be able to show. So let's have a look at each of these. So the first one was y equals f of x plus 1. So the graph originally looked like this. What happens with this now? F of x, nothing happens to the function itself in terms of x changes. The plus 1, we know that that shifts the entire graph up 1. So you'd imagine we have the graph in its original place, we shift the whole thing up by 1. And it's then at this point we have to mark on the key bits of information. So for that we have to see where each of the points have manipulated and gone to. So this one here at negative 1, 5, there's no change in the x, but the y has changed, so the y has gone up by 1. So it's now at negative 1 still in the x, but 6 in the y. This one here hasn't changed in terms of x, but it's gone up by 1 again. So you've gone up to 4. And the one here at negative 4, well, it was at negative 4, 0. It's now shifted up to here, and it's now at negative 4, 1. Don't try and assume you're making new points anywhere. So don't imagine you know what this coordinate is, and you're going to show a coordinate there. You don't know what that is. These are the ones that you know. These are the ones that you have to show. You then have to label it at the end, so I know that that's y equals f of x plus 1. Label it correctly when you're done. Second graph transformation was this. So we've got y equals 2 f of x plus 1 here. So we have to think of what each of these do to the graph on its own. So we start with the bit in the bracket. So x minus 1 here, well, that shifts everything in the x direction. That's an x shift. And remember, it's the opposite. So minus 1, remember for y minus 1 we move down in the y direction. But for x, a minus actually moves up in the x direction. So it takes a graph and it shifts the whole thing up by 1. So everything moves that way. And then the 2 in the front stretches the graph. So it takes the entire graph and it stretches it in the y direction. So it moves everything up and it doubles where everything is. So this point here that was at 0, 3, well, it shifted to the right by 1. So it's moved in the x direction to 1. And it's stretched too, so it's doubled out in size. So it'll have gone from the 3 to the 6. It'll have stretched in that direction there. The point that was here, negative 1, 5, shifts here onto the y-axis, and then the 5 stretches up to 10. So that would be at 0, 10, or you could just mark it as 10 because it's the y-axis intercept. This one here is at negative 4 in the x direction. It shifts across to negative 3, but it's got no y value, so when we stretch it, when we double it, nothing happens to the y value, it stays the same, so it goes there to negative 3. So we know in this case y equals 2, f of x minus 1 is given by this sort of graph here. The final graph we had was one that looked like this. So we had our same graph here, but we were after y equals negative f of 2x plus 1. So it's breaking it down and imagining what happens. So the 2x part here squashes it in, so it halves all of the x values. So the x value for this one goes to negative 1/2, this one goes to negative 2, this one doesn't change, it's already on the x-axis, so it squashes it. The negative part then flips the entire graph. So it flips the entire graph in the x-axis. So what happens is the graph looks like this. The entire thing gets reflected in the x-axis just like a mirror. We then have it saying plus 1, so everything then shifts up 1 in the y-axis. So it looks something like that. What we now have to do is figure out how each of the points have changed and mark them on. Well, the first one, let's look at the 3. So nothing happens with the x transformation. That still stays on the 0. When we flip it, it goes from 3 down to negative 3. We then shift up 1, so it goes from negative 3 up to negative 2. So at this point here, it is now located at negative 2. The negative 1, 5, well, when the x transformation happens, that gets squashed in and halved. So the x value goes from negative 1 to negative a half. The y value flips, so it goes from 5 to negative 5 down here, and then shifts up 1. So that then goes to negative 4. And this one here, x value with a squash goes into negative 2. With the flip, nothing happens to its y value. It has no y value at that point. And then we shift it up 1. So it actually ends up there, negative 2, 1. We then have to tell us what the m is. So we know in this case, y equals negative f of 2x plus 1. That's the graph we've just sketched. All these different types of transformation can occur on their own or in combinations. At higher level mathematics, you're looking at 2 or 3 different combinations together. We need to know how each of these affect the graph and what happens to the coordinates so that we can mark on those key bits of information when we're doing it. Well done. I will see you in class for a bit more work and some help.